Hello guys, today we're doing lead question 16, free sum closest. It's a medium question and it is given an integer array nums of length n and an integer target, find three integers in nums such that the sum is closest to the target. Return the sum of the three integers. You may assume that each input would have exactly one solution. Example 1, nums is equal to -1, 2, 1, -4, the target is 1. And the output is 2 because the sum that is the closest to the target is 2. -1 plus 2 plus 1 is equal to 2. Example 2, nums is 0, 0, 0, target is 1, so the output is 0. The sum that is closest to the target is 0, 0, 0. So the way we're going to do this is similar to free sum, but instead of setting, we don't have a sum pretty much. So what we would do is we'll check the values and set them to an absolute, set the sum to absolute value, and we get the difference between that and the current sum and set it as the smallest gap pretty much between them. Let me show you how it's done on the whiteboard. This is our array. The first thing we do, let's say we have a target value first. So target is equal to 1. The first thing we do is we sort our array. So our first value will be -4, second value will be -1, and the last value will be 2. So it will be 2, -1, 2, -1, and -4. So the next thing we do is we set a sum variable, which is representing our current sum of our integers closer to our target. So we set it to infinity because we know that our sum will be closer than that when we get it. Then we have to loop through the array, so we have an I value, and within that loop we have a while loop, which we set j as a variable, which is equal to I plus 1, which is 1, and k as a variable, which is equal to numbers of length -1, so that's 3. And as long as j is smaller than k, we continue. So we're going to have some other variables represent our current sum and our distance. Oh, that's a mistake. Distance. And our distance. Okay, so our current sum is going to be I plus j plus k. So I'm going to use I to represent black, red to represent j, and blue to represent k. So right now our current sum is -4 plus -1 plus 2, so that's equal to -3. And our distance is our current sum minus the target, and then we absolute it to make it a full number. So -3 -1 is -4. We set it to a whole number or a positive number, which is now our distance equal to 4, which is correct. As you can see, -3 to 1 is 4 in distance. We check if our distance is closer than our sum minus our target, which gets our previous closest distance. So infinity -1 is still going to be infinity. So we're going to set it to our current distance, which is equal to 4. Sorry, not current distance, current sum, which is equal to -4 plus -3 as we have there. Then we check, is our current sum smaller than target? If it is, we increment j to get a bigger value to get closer to target. If it's bigger than target, we decrement k to get a smaller value and get closer to target. But right now it's smaller, so we increment j. J is now 2, and we are at 1. So we get our current sum again. Our current sum is -4 plus 1 plus 2, which is equal to -1. And our distance is our current sum minus our target, so -1 minus 1 is equal to -2. And then we set it as a positive integer. So now the distance is 2. We again check if our distance is smaller than our sum minus the target. So our sum minus target is equal to -4. We absolute it to get to a positive value. So is 2 smaller than 4? Yes. So we know that current distance is 2, and we set our sum to our current sum, which is -1. Then again, our value is smaller than target. Our current sum is smaller than target, so we increment j, but that will break the while loop. So then we have to increment I instead, because the while loop is now broken. We increment I. So now I is equal to 1, and j is equal to 2, and k is still equal to 3. Because 1 plus 1 is 2, and the length is still 3. So right now we have a current sum which is -1 + 1 + 2, which our current sum is now 2. And now our distance is 2 minus 1, so our distance is now 1. So we check if our distance is smaller than sum minus target. So sum minus target is -2, and we absolute it to a positive number again. So is 1 smaller than 2? Yes. So we set our sum as the current sum, which is 2. And then now we can't increment the j with increment k again because it will break the while loop, so the while loop will break. And if we increment I again, there will be no there'll be no while loop again, as there's only 2 numbers left. So that's the end of our function, and we return our sum, which is equal to 2. Let me show it's done in code. So the first thing we do is we sort our array. So nums.sort, we sort it from smallest to largest. So for each value, we set the smallest first and then the largest. This sorts from smallest to largest. Then we set a sum, set to infinity. Now we loop through the array. So for let I is equal to 0, because I is smaller than nums.length, we can do -2 because we have 2 pointers after that. Then we increment. Then we check. We set a j value, so let j is equal to I plus 1. And we set k value, let k is equal to nums.length -1. Then we have a while loop. While j is smaller than k, we keep iterating. Then we check if our current sum is closer to the target than our previous sum. So we check if nums I plus nums j plus nums k minus target. Oh, why'd I go over there? Minus target. Remember, we have to absolute to a positive value, so we set this as, in brackets, as math.absolute. We'll check if it's smaller than, again, math.absolute, our sum minus our target. So we're getting the distance. If our distance is closer, then we set our sum as nums I plus num j plus num k. The sum of the integers. Else we continue looping, and then we return our sum as a result. Let's see if that passes. Time limit exceeded. Let I is equal to nums I plus plus. Oh yeah, sorry, we have to increment j. We check if our current sum, so nums I plus num j plus num k, if our current sum is smaller than target, then we increment k. Sorry, we increment j. Else, if it's bigger, we decrement k. We was going through endless loop because we're just staying in an endless loop of j being smaller than k, it's not incrementing the values. Now, to solve the problem, see if that passes. It does. Let's submit. Time limit exceeded. Okay. 1 1 1 1 target 0. While j is smaller than k. If nums I plus nums j is smaller than target j plus plus. Was k minus minus, let I j is equal to I plus 1, let k is equal to nums.length -1. Ah, this does not happen here, sorry. Oh, this happens outside of the if statement, because if they're not smaller than target, then it doesn't increment, but we need to increment at each step. So let's submit this now. That should pass now. Fix this so it's better. Perfect. As you can see, this is the fastest time, well, one of the fastest time complexities, and also beats most people for space complexity. Time complexity for this is O(n)², as we're looping through the array once, and within each value we're looping through the array again. And the space complexity of O(1), as we're storing constant variables here. Thanks for watching.